These are our epsilon delta proofs. And so what we're going to be doing is showing that this is true, and if this is true, then this is true. So we're going to be building this into this. It's our limit, right? So we're taking our x approaching 3 and showing that our 2 of x is approaching 6. And so we have two things that we get out of this little proof. Remember, 2x minus 6 is less than epsilon, and x minus 3 is less than delta. So we already knew that from previous epsilon delta stuff that we dealt with. So how we do this is a little backwards. What we're going to do is take the 2x minus 6 is less than epsilon and turn it into this. By doing that, it's going to show us the steps we need to turn this into this one. So again, our goal is to turn x minus 3 is less than delta into 2x minus 6 is less than epsilon. And so we start here and work backwards like this. So this is just your workspace. It's not our proof, it's just our workspace. So if we factor out the 2, we can now take the 2 outside of it. And the reason we factor out the 2 is I'm just looking over here in what I need. And you see there's just an x here. There's no 2 in front of the x. So I need to factor that 2 out to get my x alone. Now I can take and divide both sides by 2, giving me my x minus 3 that I wanted. And so we know that this is our delta. And so we can say delta is equal to epsilon over 2. Now we have our starting point. So we can come over here and say x minus 3 is less than delta. That's our starting point. So if this is true, so we're saying this is true, then this is true. And so we already know that delta is greater, has to be greater than 0. We know our epsilon is greater than 0, so it's true. By replacing it, we are creating a delta that is still greater than 0. So we're just replacing it. And then now we just backwards work it. So this becomes this. And then we factor the 2 back in. And in fact, you can make that all one step if you wanted to. 2x minus 6 is less than epsilon. And there we have it. So this is true. Delta is greater than 0. Epsilon is greater than 0. Works perfectly fine. And then we show that this becomes this. So we just proved that that is true. So now we can say, therefore, the limit as x approaches 3 of 2x equals 6. So it's easier to just start with what you're looking for and work it backwards. And then you just copy it back down and you have a nice proof. So let's try it again. So here we know that x minus 3 is less than delta. So we're going to be starting there. And so what we need to do now is find out what is our delta in terms of epsilon. So we take our 4x minus 5 minus 7, and we say that's less than epsilon. And again, we use our workspace over here to combine them. So 4x minus 12. And just like before, we don't want that 4 in front, so we're going to factor it out. And you can see there is our epsilon over 4. So just like before. So we would say that delta is epsilon over 4. So by replacing delta with epsilon over 4, again, both are greater than 0. We just now look back over here and we write that one in that form and that one in that form. You're just recopying them back the way they were. Oops, that's a 12. And then finally we write 4x minus 5 minus 7 is less than epsilon. Therefore, the limit as x approaches 3 of 4x minus 5 equals 7. See, these limits already are true. And since they are true, this is working perfectly fine because they're true. So we're just proving that it's true. So again, we're starting with what we know is true. This is greater than this. We know that epsilon is greater than 0, so delta is greater than 0. And we're showing that because this is true, which is proving our limit. All right, let's do one more. So again, this time we're going to write it all out all by itself. So we're starting with x minus 4 is less than delta. And we're going to use that to show that 1/2 x plus 1 minus 3 is less than epsilon. And so we're going to do some simplifying to get this down to x minus 4. So again, that's our goal. And it's going to tell us what to set our delta equal to. Not the 8, the delta. Okay, so this would be 1/2 x minus 2. And then we need this to be just plain old x, so I need to factor out a half. And so that would now become a 4. And you can check that very quickly. 1/2 of 4 is 2, so it works perfectly. And you see now that gives us our x minus 4. Multiplying both sides by 2, we get 2 epsilon. So our delta is 2 epsilon. So coming back over here, x minus 4, 2 epsilon. And then we just, again, rewrite everything in reverse. So this would become 1/2. So it's a nice little trick, right? 1/2 x minus 2. And then 1/2 x plus 1 minus 3. You don't have to even think. It's like your proof is just being copied. So this is the reverse of your proof. And so you just recopy it. And therefore, the limit as x approaches 4 of 1/2 x plus 1 equals 3. See, so looking at our rule, right? If this is true, then this is true proves this. So if this is true, we create this one. So this is true. And from that, we have shown that this is true. That proves our limit. Okay, so one more, and just to show you, it doesn't really matter how messed up they are. We work the same way. So I'm going to zoom in to give myself some more room. So again, we're starting with x minus 2 is less than delta. And we're going to try and show this. So we want x squared plus x minus 6 over x minus 2 minus 5 is less than epsilon. So I'm going to zoom in. And so we're going to convert that into x minus 2 is less than, and we'll find our delta from that. And that'll tell us where we start. All right, so how you want to start this is just like other rationals. You want to start by factoring the top so that you can see if this simplifies, and it does. So 3 minus 2 is 1, and 3 times negative 2 is negative 6, and you can see they cancel. So we end up with x plus 3 minus 5 is less than epsilon. And you can see just by simplifying that, we get our x minus 2. So that's our delta. So delta is going to be epsilon. So we get x minus 2 is less than epsilon. And then we just rewrite it in reverse to show that it's true. So we're building this up in the same way. And so what we're saying here is that 3 minus 5 is negative 2. So that is true. And then we're saying, well, x plus 3 is x minus 2 over x minus 2 minus 5. And we're dealing with limits here, not values. So that's fine to do. You can introduce an undefined. And this now is that. So we just have to expand it out. So x squared plus x minus 6 over x minus 2 minus 5 is less than epsilon. So we showed it. So this is true. And by building that up, we have said this is true, well, which means this has to be true. Therefore, the limit as x approaches 2 of x squared plus x minus 6 over x minus 2 is 5. And there you have it. There's our problem. So again, work with your result, your goal, which you want to get, backwards until you get the starting point. And then now you have your starting point, and you can then just build it up. So this is true, the limit exists. Thank you.